The chi-square test for independence of two variables is a test which uses a cross-tabulation or contingency table to examine the nature of relationship between these variables. It is used to test the hypothesis of no association between two or more groups, population, or criteria. If you are interested in comparing the counts of categorical responses between two independent groups, you need to develop contingency or cross tabulation and run chi-square test. For example, your company launched a new advertisement campaign and wish to know response for it among different customers. Similarly, your company sells 3 products in 2 geographic locations and you are asked to ascertain whether the sales in these 2 geographic locations are same or not. In Excel, you don't have a direct command to compute chi-square test. You need to do it manually. First, you need to create a contingency table or crosstab similar to one shown in New Age Group Excel workbook. With the help of Excel pivot table tool, you can create such cross tabulations with simple drag and drops. The table provides information about different age groups of a people turned to different media for news. You need to find out whether there is statistically significant relationship among age groups and news preferences. The chi-square test for independence begins by assuming null hypothesis that there is no relationship between the groups. The alternative hypothesis states that there is some relationship between the groups. The first step in computing chi-square test of independence is to compute the expected frequency for each cell. The equation to compute expected frequency is row total into column total divided by grand total of observed frequencies. Create a expected frequency table template akin to observed frequency table. In first cell, that is local TV and under 36 type equals to, and select local TV row total, that is 359. Enter multiplication symbol and select under 36 column total, that is 402. Enter division symbol and select grand total, that is 1434, and press enter key. You get first cell expected frequency, that is 101. If you drag this formula to other cells, Excel gives error message. This is because of Excel cell references. To make rows and columns constant, you need to use dollar symbol before row number and column name. Observe the formula in formula bar. Grand total value is in cell E11. First, you make this cell constant by typing dollar symbol before column name and row number. When you put a dollar symbol before column name, the column becomes constant. And when you place dollar symbol before row number, then the row becomes constant. When you place dollar symbol before column name and row number, that cell will become constant. Your row totals are in column E. To make this column constant, put dollar symbol before E. Next, your column totals are in row 11. To make this row constant, type dollar symbol before 11 in formula bar. Now, drag this formula to remaining cells. Next, calculate totals using sum function. You can observe different values in cells, but row totals, column totals, and grand total are same. To calculate the chi-square value, use chi-test function, that is CHITEST. In any empty cell, type equals to chi-test CHITEST and select actual range, that is observed frequency. Exclude totals. Then type comma and select expected range, that is expected frequency. Here also exclude totals and press enter key. P-value of 0.004591. Since this is less than alpha or significance value of 0.05, you can reject null hypothesis and state that the media preferences is not same among different age groups of readers. To compute the chi-square test and critical values, use chi-in function, that is CHI-INV. For this, in an empty cell, type equals to CHI-INV and select p-value for a probability, put a comma symbol and enter degrees of freedom. Here degrees of freedom is total number of rows minus 1 multiplied by total number of columns minus 1. In your contingency table, you have 5 rows and 3 columns. So 5 minus 1 into 3 minus 1. That is 4 into 2 equals to 8. So your degrees of freedom is 8. Press enter key. The chi-square test static is 22.181. Now, using the same function, calculate chi-square critical value. Type equals to chi-inverse and this time enter your significance value, that is 0.05 for probability and 8 for degrees of freedom. The critical value is 15.50. As your test static value is greater than your critical value, reject null hypothesis and you can conclude that different age group people turn to different media for news.